So last day, we started talking about adding and subtracting fractions. For the most part, it should have been a review of grade 8, right? We mentioned that if you want to add or subtract fractions, the denominators need to be the same, right? That's the phrase common denominator. And we also talked about, hey, if a fraction has more than one negative sign on it, we simplify that fraction down. We combine those two little dots down, we simplify it so it's overall positive or negative, right? There you go. Well, here, so on day 4 there. Okay? All right. So, first question here, where we left off, is checking for negatives. Each fraction only is either positive or one negative sign, so there's nothing really to combine here, right? And so we go straight to checking the denominators. We have 10 and 5, all right, as our denominators, and we want them to make them the same. So we need to find our common denominator. So either we know our multiplications, we can do it quickly off of our head, or I mentioned you can use your multiplication chart, right? So you find your two denominators, 10 and 5 in this case, and we look for the common multiple. What would that be? What is our common multiple? Phoenix? 10, right? And there's lots of them, but we just pick the smallest one, right? So then we go back to our notes here, and we go, let's change the denominator to 10. The first one doesn't need to change. It already has a denominator of 10. So we can rewrite this as is. But the second fraction needed to change because we have a 5 on the bottom. We go, okay, what do we need to multiply to the 5 to turn it to the 10? 2. Thank you. So we multiply the bottom by 2, but remember, also the top, because we want to keep it equivalent, right? So we multiply the top and bottom. So this gives us the denominator of 10, and 2 times 2 gives us a 4. And we still have that negative sign, and I'll place that up on top. Okay, now we had that in brackets. The brackets aren't really necessary, but it helps isolate numbers. And we have a negative sign outside. So when we're combining, remember the denominator doesn't change. It's the numerators we look at. And we just follow the math operation. So it goes 3 minus negative 4. Let's write that out. 3 minus negative 4. What would that be? What number is that? All right? What does that equal? What is 3 minus negative 4? Goshan? Sorry?
7.
Yeah. Right? Now, you're welcome to use your calculator, but also, going back to talking about integers, when you have two negatives like this, side by side, those can also be combined to make a positive. So these two negatives make a positive. So that could have been rewritten as 3 plus 4. Okay? So not only, and 3 plus 4 is equal to 7. So not only do we check to see if a fraction has multiple negatives on itself, but you also look for the negative out front, because that can change how we add and subtract as well. Okay? Now, so let's look at, oh, sorry, and that should have been a 7. Okay. So let's look at the next situation. Okay? We have this number here only has one negative. This number here only has one negative. But this has a negative out front and a negative out front of it. So there's some canceling we can do here. Right? And I'm going to do a little side example here. And I'm just say negative 2, oops. Right? Negative 2 minus negative 1. Okay? So the negative out front of a bracket can cancel the negative inside the bracket. So that becomes positive 2. Right? And we typically don't really need to write down a positive sign to indicate if something's a positive number. It's just understood. And if you do the same idea for the next one, a negative makes a positive, becomes a 1. Right? And if now there comes an issue. It's like, hey, we went from this number minus this number to just having two numbers sitting here. Right? There's no math operation. Yes, Max? Sam? Can you wait a second? All right, let's just do this question here. So if you're combining negatives and it becomes a positive and it's between two numbers, you need to show that plus sign, like in this situation here. So it translates to 2 plus 1, not just a 2 and 1 floating there. All right? So if it's in between two numbers, you need to show that positive sign. All right? So let's look at that. So here, using color coded, this negative and this negative cancel each other out to make a positive number. Right? And same thing goes with this one. This negative and this negative cancel out to make a positive sign. But now we lost our math operation between these two numbers. So we need to show that positive sign so we don't lose that math operation. Okay? Pretty straightforward to follow? Right? All right. So now that we dealt with the negatives, we look for a common denominator. And this becomes a little bit trickier, 15 and 6. Right? That's why I gave you that huge multiplication chart. Right? We have 15 and 6. 15 here, 6 here. What multiple is the same? I'm going for Max this time. 30. 30, thank you. Right? So we have 30 here and 30 here. That's your common denominator. Right? And there's other ones in there as well, but we picked the lowest one. Okay, so next question here. So continue on with this question. So we need to make the bottoms 30. So for the first denominator, what do we multiply it by to turn it to 30? Max? 2. And that's not the bottom, but it's also the top. All right? So let's rewrite this. So the denominator turned to 30, and on the top, 12 times 2 is 24. And going to the other one, what do we need to multiply the second fraction to turn it to 30? 6 times what? 5. Jack? 5. Thank you. So we multiply it by 5 and 5. Right? So this becomes 30, and 11 times 5 is 55. And we carry that plus sign down. Right? So overall, we have our denominator doesn't change when we're adding and subtracting. What is our numerator? Phoenix? 79. 79. 24 plus 55 is 79. Okay. Now, can this be reduced? That's another thing we should be checking. Can this be simplified? All right. I don't know. Let's look at 79 on a number line. All right. Using a number line here, 79 doesn't have any dots above it, right? So it is a prime number, so it can't get any smaller, right? So the only way you can make 79 smaller is dividing by 79, right? So the denominator doesn't have 79 in it, so that's the smallest it's going to get, right? So this is our final answer. All right, Sam, you can go now. All right. Okay. So onto the back page. We won't do the right side. I'll just focus on the two word problems, and we'll leave you be from there. Okay? Okay. So the first problem goes, on a January day in Prince George, the temperature read negative 10.6 degrees at 9 a.m. and 2.4 degrees at 4 p.m. The question is, what is the change in temperature for the first part? The second part, what is the rate of change? Okay. The word change is used a lot in math and science. Okay? there's a set way to always calculate change. Because you can find the change in temperature, change in speed, change in concentration. Lots of things you can find the change out. So one thing you're going to need to know for next year is that change, how do you calculate change? It's always your final reading minus your initial reading. Doesn't matter what you're asked to find the change of, it's always final minus initial. Right? What's the difference of what you started off from and where you ended up? That's what changes. Where you started, where you ended, what's the difference? Right? Okay. In this case, we're trying to find the change in temperature. So what was our final temperature? What would that be? Off this question. What is our final temperature here? Where did we start in temperature and where did we end off? Right? So the temperature read this at 9 a.m. and it read this at 4 p.m. So what's our final? What's the temperature at the end? Right? Max? Yeah, 2.4 Celsius. That's the one in green, right? And where did it start? That's our initial one. What temperature, Goshan? 10.6. Not just 10.6, negative 10.6. Right? That's in the black here. Negative 10.6. And we are subtracting these two numbers. Right? So change is always final minus initial. The difference between those two things. That 10 does not, 0 does not look very nice there. Right? So what is 2.4 minus negative 10.6? This is the same situation. Two negatives touching each other become positive. 2.4 equal signs plus 10.6. What does that equal? Yes, Phoenix? 13. Thank you. And it's 13 degrees Celsius. Right? That's how much temperature went up. Started at negative 10.6, went up to 13.6. Right? And this is the reason why you always go final minus initial. It tells you the direction as well. Right? The positive means it goes up in the positive direction. Negative would mean it goes downwards. Right? Okay. Now, the next part is find the rate of change. Now, that's another math science term that we come across all the time. Rate, if you're ever asked to find it, it's always equal to your change divided by the time it took for that change to happen. Right? Okay. What's the change in temperature? How long did it take for that change in temperature to take place? Your rate's always like that. Right? Same, like if you're be asked next year to calculate speed all the time. It'd be like, how far did you move divided by how long did it take you to move that far? That's your speed. Okay, so our change is in temperature is the 13. Our time is how long it took for that to happen. So how long did it take for that to happen? This temperature, first reading was at 9 a.m. Second reading was at 4 p.m. So how much time is that?
8 hours.
Sorry?
8 hours.
8 hours? Right? Max? 7? Let's just count it, right? 10, 11, 12, 1, 2, 3, 4, 7 hours, right? So our change is 7 hours. Okay? Now we just calculate this value. Remember, the fraction line just means to divide. So we grab a calculator and we go top number divided by bottom number.
1.85.
Thank you. 1.85. Right? So we'll round this to just 1 decimal point. If I want this to just 1 decimal point, what would our number be?
1.8.
No?
1.9.
1.9. We look at the number before, and that tells us to round up. 5 or higher tells us to round up. So it's 1.9. So now, this 1.9 doesn't have any units attached to it. It should, right? Yes, Max? Close. Right? There's two numbers this came from. The change was measured in degrees Celsius. The time was measured in hours. So what's the change? The top number divided by the bottom number. So the top unit divided by the bottom unit. Degrees Celsius, and this little slash means per hour. 1.9 degrees Celsius per hour. That's how the speeds are measured too. Like if you have something like this, kilometers, kilometers per hour, right? You divide distance divided by time, right? So just look back to the numbers you're dividing to figure out the units you are using. Okay. Final question. All right, the Rodriguez family has a monthly income of $6,000. They budget a third for food. Let's highlight these. They budget a quarter for rent, a fifth for clothing, other highlighters, and 10th for savings. How much money do they have left over after their expenses? Right? So we need to figure out how much money they're spending on each item. Right? So let's calculate.
Do we convert them to decimals?
Well, yeah. Well, with money, it doesn't make sense to leave the answers as fractions. Right? Right? So we always convert to dollars and cents. Right? So we have here a third for food. A third of what? A third of $6,000. That's their budget for the month. Right? Now, last day or the previous lesson, I said the word of means to multiply. Right? So a third times $6,000. How much money is that? 1,800? Is it?
I told him the decimal of 1.3 times 6,000.
Yeah. So decimal of 1.3. So 1 divided by 3 is 0.33. 3, continuing. And we multiply that by 6,000. And it should be 2,000. Right? Or, if you don't like the way that looks, just remember, this is just 6,000 over 1. You multiply the tops together, you multiply the bottoms together, right? And you go top divided by bottom. What's 6,000 divided by 3? It is 2,000. Okay? So we do the same thing for the rest of the items. So next one was rent. And they spent a quarter of 6,000. So how much does that equal? A quarter of 6,000. Use your calculator. Figure out what value is that. What number would that be? Yes, Max. 1,500. Oops, that jumped. Oh, where did we go? 1,500. Okay. Then we also have a fifth for clothing. And that was in yellow, so I'll use maybe orange. Clothing. A fifth of $6,000 for clothing. How much does that equal? $1,200. That sounds about right. 1,200. And finally, your savings. You're budgeting for vacations or maybe retirement. They're saying they're going to save 1/10 of their monthly income. So how much money are they saving each month? Right. What would that be?
I got 600.
Yeah. It'd be 600. Okay. So the question asking us, how much money do they have left over after all their expenses and their savings account? So we need to find out how much money have they spent, right? So they spent $2,000 here, $1,500 on rent, $1,200 on clothing, and $600 from savings. So if we add all those numbers up, what do we have? How much money did they spend? Right? Grab your calculator. Add those four numbers up. So we have 2,000 plus 1,500.
5,300.
5,300. Thank you. It's $5,300 they spent. So how much money do they have left over at the end of the month? 700, yeah. So amount left over is $700. And how did we calculate that? Well, we had $6,000 and we spent $5,300. What's left over? $700. Okay.